So let's remember what those ratios were. And you need to come up with a way that you can remember what those ratios are. I had a teacher, it was a professor once, say, some old hog came around here, took our apples. And I thought that was just such a weird thing. Some old hog came around here, took our apples. So let me try typing that out for you. Some old hog came around here, took our apples. And I just always remember that. I just remember the first letters, S-O-H-C-A-H-T-O-A. So, and those are the ratios right there, okay? So the first one, S, that's sine, and it's equal to O over H, which is equal to the opposite over the hypotenuse, okay? The second one, C equals the cosine, and it's equal to CAH, so that's the A over H, which is equal to the adjacent over the hypotenuse, right? And then T equals the tangent function, which is equal to the, O slash A, took our apples, so O slash A, which is equal to the opposite over the adjacent. Okay. And then, of course, the critical thing here, you're going to make big mistakes, is making sure you know which one's opposite, which one's the adjacent, which one's not. Because if you make a mistake with that, you're going to have troubles. But knowing this and kind of trying to remember this can be helpful in solving these kinds of problems. So here's what it says. It says, select the correct value for each expression. Well, here it says, we have a right triangle. I'm going to use my highlighter here to show it to you. I'm putting this one in yellow. There's one right triangle right there, ECB. And notice that angle B here is marked with two markings, two arcs there, which tells us it's congruent to this angle right here, which is also, I'm going to go with a different color now, pink. It is also part of this big right triangle right here. So this whole big right triangle right here has the same two pieces marked. Well, guess what? By angle-angle theory, I know that this pink one and that yellow one, by angle-angle similarity postulate, I know that these two angles are, or these two triangles are similar. So whatever the ratios we want from angle B, I could be thinking about also this triangle here, angle C. And then you have a third triangle, right? And that third triangle is, we'll see if we can do this in blue, it's this one. And also we see that we have inside of this triangle AED, we're talking about angle D here. So when it asks you in the problem the sine of angle B and gives you possible ratios, we have to remember that the answer is not necessarily going to be given in this yellow triangle. It could be given in the pink triangle, or it could be given in the blue triangle, as long as we consider this angle to be, we know that it's congruent to this angle, so these would be the same ratios, and this angle, so those would be the same ratios. So let's just kind of work our way through it and see what we can do. So the first one says the sine of angle B. So the sine of angle B, which is this one. So remember, sine is, what is sine again? Sine is, it's the opposite over the hypotenuse. So the ratio that would be correct, the opposite side from B, I draw a line and see my opposite side is right over here. It's side EC, and the hypotenuse of this yellow triangle, which is the only triangle that really has B as an angle. And so the hypotenuse would be here. So there's my opposite right there. That's my opposite, and there's my hypotenuse. So the simplest answer would be EC over EB or something like that, EC over EB, but of course they haven't given me that. So now I got to look for some other possible solutions. If I'm looking at the pink triangle, the opposite side from the angle that is congruent to B would be this side over here. Right? So this could be my opposite here. AD over my hypotenuse would be DC of the pink triangle, right? So there's my hypotenuse there. So do I have AD over DC or something like that? No AD on top. So that's not going to work. So how about over here, the blue triangle? Okay, so in the case of the blue triangle, well, let me get my eraser and kind of get rid of, oh boy, that's, better get my eraser a little bit smaller here. Not quite that small. All right, so let's just get rid of those markings. So from just thinking about my blue triangle, the opposite is AE, so this would be my opposite, and my hypotenuse would be DE. So I have AE over DE. Well, I don't have that either. I don't have opposite over hypotenuse here. Right? That would be my hypotenuse of the blue triangle. So I don't have that either. So now I have to think some more. This AC over DC is not going to work for me. It's AC over DC, and that's not going to work. AE over AD, that is not going to work either. How about the sine of CDA? So the sine of CDA. Well, the sine of angle B is not equal to the sine of the angle opposite, so that's not going to work. The cosine of angle AED. Aha, well this is very good. This is something we haven't talked about yet, but the sine of this angle of the blue triangle is equal to the cosine of that triangle. Let's see why. Ready? So the sine is equal to the sine of angle D, so we go sine of angle D would be equal to the opposite of angle D, that's AE. So it's equal to AE over, that's the opposite, over the hypotenuse, which is DE. So my opposite over my hypotenuse, that's the sine of angle D. Well, let's come over and think about only this blue triangle. Now let's do the cosine of angle AED. So the cosine of this angle, remember the cosine of that angle is equal to the adjacent. And the adjacent is AE. Ooh, I got to get my pen out so I can make better looking things. But AE, that's the adjacent over my hypotenuse, which is DE. So, wow, my sine of angle D is the same thing as my cosine of the opposite angle, the other angle in that triangle, not the right triangle, but you know, the other third angle here. The sine and the cosine are the same things because the sine is the ratio of this over that, and the cosine of this one is the ratio of this over that as well. So when it says the sine of angle B, I can find the congruent side, and I know this is the sine of angle B is the same number, same ratio here, and the cosine is going to be of angle E over here, this one right here, is going to be the same exact number. So my answer for this one is going to be right down here, the cosine of that sucker. Okay, what does the next one say? The cosine of angle B. Well, the cosine of angle B is equal to, here we go, angle B, the cosine. I'm going to do some erasing real quick. Let's erase all this stuff out. Try to remember yellow, blue, and pink so I don't have to do those again. Here we go. The cosine of angle B, well, the cosine, so that would be the adjacent side. This is the adjacent side, so this is my adjacent side over my hypotenuse. So cosine of angle B literally would be BC, the measure of BC, over the measure of BE. BC over BE. That would be my ratio here. So let's find something that is the same thing as BC over BE. So the cosine, let's see, AC AC over DC. Aha! Now let's look at this. This angle B here is congruent to this angle B here. Remember, this was our what? This was our yellow, I think, and this was our big pink one, right? So the yellow triangle and the big pink one are similar, and these two angles, this part of angle C right here and that angle there, those are similar. So I can say that the sine or the cosine of this angle is going to be the same as the cosine of that angle. So what's the cosine of this angle again? Well, it's the adjacent side, AC, right? AC, right there, over the hypotenuse, DC, over DC. So this one matches right here. Okay. Ooh, these are kind of tough to see. I know they are. Okay, next one. The tangent of angle B. Well, what's the ratio that's the tangent? Here we go. Let's erase some of this stuff out here again. The ratio that is the tangent. Well, the ratio that is the tangent. Here we go. Let me make this a little bit smaller in here and see if I can do a little bit better. So the tangent, that is, remember, took our apple, so it's the opposite side. So this one would be like EC. That's my opposite from angle B over my adjacent to angle B, so that'd be BC. All right, so not involving the hypotenuse at all, right? So let's see, AE over AD. Hey, that one does not involve the hypotenuse at all. So let's look, this would be my blue triangle. Remember the blue one that we had in here before. And angle D would be the part that corresponds over here. Angle D corresponds to angle B right there. So tangent of angle D is the same as tangent of angle B because they're congruent parts of similar right triangles. So tangent of angle D is, remember, tangent is opposite over adjacent. So the opposite of that would be AE. So there's tangent, that's good so far, over the adjacent, which is AD. So this one right here is going to, ooh, now I can make my line a little bit thicker. All right, so there we have an answer for that one. So we go into our Khan Academy and we'll mark our answers. What was it? Cosine of angle B, boom. Then we had tangent of angle B. And then we had this one, cosine of angle AED. Do we have to do this last one? I suppose we do. Let's go back and look at that one. What is sine of CDA? Oh, this is tough, man. Sine of this angle here. Now, this angle here going all the way down does not have the same markings as B. So it's not going to be one we can compare to B. But, you know, what would we say the sine is? So the sine of CDA is going to be the opposite side, so that's AC. Let me make this a little bit smaller, see if I can do this again. Here we go. So the opposite is AC, so this is like AC over my hypotenuse, right? Which is going to be DC because CDA is this triangle, so my hypotenuse is DC. So AC over DC. So now think about if we were going back to terms and just thinking about it in terms of angle C. Okay, what would that be? Well, AC is the adjacent, right? So this is really our adjacent for angle C, the congruent angle to B. The adjacent, that's a J, right? Sorry, over our hypotenuse. The hypotenuse is still the hypotenuse, right? And we're using a different angle. So adjacent over hypotenuse is the cosine. So this one is the same ratio given the sine of this is equal to the cosine of that. So it's going to be equal to the cosine of angle B. So this one gets answered right here as the cosine of angle B. It's another way of writing the cosine of angle B. And that's how that's done.